Yeah, thank you, Joppe, for the introduction. As Joppe mentioned, my name is Alex, and I will be giving you this course, which is an introduction to programming with Python. Myself, I studied in Eindhoven as well at the TU. I studied mechanical engineering. So most of you may be wondering now why a mechanical engineer is going to teach you how to program, which is a valid concern. So let me take that away a bit. So during my master's, I figured out that I was way more interested in the software parts of all the courses I had. So I decided to take on some programming courses and did a lot of self-study. And also in the student team that I was involved in, I did a lot of software tasks. And right now I'm also working at a software company, Invest. So I do have some experience, and I hope I can transfer some of that experience to you guys today, and hopefully also enthuse you a little bit on programming in general. So I want to thank Service and of course for giving the opportunity to give this course, because I think it's becoming more and more relevant that everyone in the tech industry has at least a basic understanding of what programming actually is. This doesn't hold only for computer science anymore. I think it holds for every study in the tech industry. So that's also good to see that so many people of architecture, I don't know a better English term for bouwkunde, but showed up. So I hope I didn't offend anyone with that. But so let's start right away. So I call this course an intro to programming with Python instead of an intro to Python, because before we dive into Python, I just first want to go over what programming actually is and a bit of a history behind it, so that people actually know what you're actually doing. So this is separated from any language that you need to learn. Just know that if you write code, how does your computer actually know what it has to do with that, what you're writing? So, and then after that, we'll go into Python more. So the contents of this course are as follows. There's 3 main parts, and for sure we're going to go through the first 2 in these 2 hours I think we have. I'm not quite sure if we can make it to part 3, but I added it anyway, but the most important parts are 1 and 2. The first part will be an intro to programming in general. So what is programming, and why are there so many different programming languages? And of all these languages, why we choose Python? And the second part is the fundamentals of Python. So the data types we know, operators, conditionals and loops, functions, and some other Python specifics. And then, as I mentioned, if there's time for a third part, we'll do some intro to more advanced topics, such as object-oriented programming and maybe analyzing data from a text file or something. If you want to ride along with some stuff, I definitely encourage you to do so. If you don't have Python installed, you can still ride along. If you go to this link, if you have a Google account, which I assume most of you will have, if you go to that link, you can open an IDE in your web browser, and you can type Python script in there. If you really want to, but you don't have Python installed, you can use that link. So the first part, an intro to programming. So what actually is programming? Well, in one sentence, programming basically is defining a set of instructions that a computer will execute. So where did this all start? So in the early 19th century, so we're talking 1800s, in the textile industry, they just used thread and needle to make cloths and stuff. And it was in 1822 that Charles Babbage proposed a way of using these punch cards that you see over here that can go through a machine, and the machine can then identify where a hole is, and at that point it will insert a needle and a thread. So using these patterns, they could process multiple patterns in cloths multiple times. So in 1842, it was Ada Lovelace, which you see here on the left, who wrote the program that should be used and could be executed by a machine. And that is considered to be the first computer program ever written. And so that was actually written by a woman, which is by a lot of people surprising, because especially in that time, women were not studying at universities and stuff. So I think always think that's a cool fact. So before we go a little bit, before we extend this knowledge on how a computer actually works, does anybody know what the counting system that we humans use, what it is called?
Is it decimal or something?
Yeah, it's we would call it base 10 in programming. No, but it's actually a good answer. I think it would mean the same thing in this case. So base 10 basically means that if we identify a number, then every digit in that number describes a power of 10. So if we, for instance, have the number 12,035, then the one at the left would mean 10 to the power of 4, and then we would have 2 times 10 to the power of 3, 0 times 10 to the power of 2, and so on. So having said that, does anybody know what the counting system that computers use is called? It's probably a more common name than base 10.
Binary?
Yeah, thank you. Indeed, it's called binary. And if you compare it to the base 10 algorithm, it's that every digit in the number describes a power of 2 instead of a power of 10. So in this case, to describe the number 25, we need 5 digits, as you can see. While if we would use the base 10 system that we're all accustomed to, we would only need 2 digits, namely 2 and 5. So this is a very inefficient system to count. So why would computers do that? Why wouldn't they just use a base 10 system? Why does a computer use only ones and zeros? Well, that's because of hardware limitations. So what your computer basically is an entire collection of transistors. So if you have a sticker on your laptop that says a Core i7 or a Core i9, then you probably have not millions, but billions of transistors, which are way smaller than the one in this picture, but probably billions of transistors in your computer. And what a transistor basically is, it's a very small electrical component that can have only 2 states. It's either on or it's off. And you can switch it on or off using a very small electric charge. So because every component only has 2 states, we can only use the binary system. If we would have 10 states, we could use a base 10 system. So we can convert any number in the base 10 system to a binary number. But how would we convert everything we write in our code so that the computer understands it? And that's where we use compilers and interpreters. So what a compiler or an interpreter basically does, for now it doesn't really matter what the difference is between them, but it's if you write your code, it will read it and it will translate it to ones and zeros and send that to your CPU, right? So your central processing unit in your computer, the brain of your computer. So that's what a compiler does. So we write our source code in either Python or C++. That goes into the compiler or interpreter, and that is translated to what they often call machine code, which is basically only ones and zeros, and that's sent to your CPU. So what is the difference between a compiler and an interpreter? Well, C++ is a compile language, for instance. So that means that you can write code in C++, and then before you can execute it, you actually have to compile it. So your compiler reads the code, translates this to ones and zeros, and creates an executable file that contains these ones and zeros, and then you can execute that executable. An interpreter, on the other hand, does not generate this executable file. It just reads through your code, and then while reading, translates it to ones and zeros and sends it in runtime to the CPU. So I don't know if some of you might have some experience with Python, I'm not sure, but then you probably know that if you write Python code, you can immediately run it. You don't have to do some compiling step or something. So let me just quickly show you that what the difference would be between these two. So I'm just gonna write a very simple, like the most simple Python script ever. So I'm gonna just write hello world.py, and only thing it does is it's gonna print hello world. Oh, sorry about that. And now I can run this hello world.py, and it prints hello world. If I would do the same thing in C++, it would look something like this. Let me, yeah, okay. Hello world. I'm just gonna write it in a different editor. Maybe it's better to read. So I'm gonna write it here. You can also immediately see that Python is way more readable than the C++. It's looks way more complicated. Let's see. Okay, save this. And now I cannot just run this code. So I have this hello world.cpp, but I cannot execute it yet. So first I have to get it through the compiler. And again, this is not relevant for this course, so I won't get into it too much. But I got it through the compiler, and then I created this executable file. And now if I run this executable file, then it prints hello world. So that's the difference between a compiler and interpreter. I don't have to do that compile step for Python files, which makes it, yeah, way more easier to debug. And for beginning programmers, that's a very nice thing. So we know how to convert any number to a binary number, but how do we do that with symbols? Well, for that we use encoding. So there's different types of encoding. You have ASCII, UTF-8, UTF-16, but there's way more. Python uses UTF-8, but it all happens in the background. You, as a programmer, don't have to worry about that. But what encoding actually is, it's just a table that matches characters with decimals. So if you type the letter A, it just converts it to this binary code and sends that to your compiler. That's all it is. It sounds very complicated when people say encoding, but it's basically just mapping values to binary code that is set in some table. So, programming languages. Why are there so many? Does anybody have any idea how many programming languages there are?
At least 10, I would say, but I guess a lot more.
It's more than 10, yes. So it's a bit of an unfair question because it depends on who you ask, but according to Wikipedia, it's about 700. And there are a lot of programmers that in their spare time make their own programming languages, a bit for fun. So there are some sites that estimate the actual amount of programming languages out there, about 9,000 or 10,000. But in the industry, roughly 50 different languages are used. So there's many different types of languages, some more familiar than others. So you probably have heard of C, C#, C++. Since you're at TU Eindhoven, you probably heard of MATLAB. But maybe some less familiar. Oh, R, I think you guys use R as well, right, for statistics. but maybe some less familiar ones are PHP or Haskell, Fortran, Go. This is a language Google created, I think, 5 years ago or something. So why are there so many languages? Because I think the answer you gave of at least 10, to someone who doesn't program, it would make a lot of sense that there would be just one language or maybe two. I mean, why would there be so many? Well, it kind of got out of hand, I think. A lot of programming languages are developed to be specialized in one specific topic. So for instance, if you want to do web development, so you want to build websites or applications on your phone, a lot of people would use JavaScript or TypeScript because they just implemented a lot of features that would make it easier to do stuff in that area. If you want to implement something on a robot that has to work in real time, so it has to decide in real time actions that it should take, it has to be very fast. So you would probably use a language like C or C++. So all these languages have their own advantages and disadvantages, which raises the question, why would we use Python? Because the first thing is that Python is an interpreted language, as I mentioned earlier, which means that it has an interpreter, not a compiler. So in runtime, the interpreter sends the machine code to the CPU, which makes it a lot slower in execution than compiled languages, because every time you run the code, it has to go over that translation again. But for a compiled language, it just has to translate it once, and then you have the outcome, and you can just keep sending that same outcome to the CPU. So it's a lot slower than those languages. So why would we even want to learn how to use Python? Well, there's a lot of advantages in Python. The first one, I think the most important one, is actually the second one. Probably should have put that at the top, but it's intuitive and very easy to learn, which was the main motivation of the creator of Python. So he wanted to make programming easier for people who didn't study computer science, which I think he achieved. So that's a very good stepping stone to get into programming, is to start learning Python. And furthermore, it's a general purpose language, so it can be used for a lot of different things. So as I mentioned before, a lot of languages are specialized in some specific topic, but Python can be used for almost anything. You can use it for web development. You can use it to create apps, or even sometimes used on embedded systems. It's often used in data science, and so it's very broad in usage. There's a large community, which is very useful and doesn't hold for every programming language, I can tell you. So it's very convenient because a large community means that when you don't know how to do something, you type it into Google and there's 100 people that know the answer for you. So that's very useful. And there's a large standard library, which I will come to a bit later. But this basically means that Python has a lot of built-in functions that make it easier to program. And all these functions, like if you would program in C, you have to manually create these functions. But in Python, these things are already handed to you, so you can just use them. Also, there's some courses in your studies that would use Python. So these are listed here. So if you're planning or already taking one of these courses, I think it's nice to have some background in Python. So that was a first part, just an introduction into programming and what the difference is in languages and stuff. And a very small introduction in why we're going to talk about Python today. If there's any questions on this, go ahead.
I do have a question. Maybe I'm working in C++ now a bit, and you mentioned that it's really useful for robots because it's really fast in relation to Python. But actually, I'm not using it for anything that has to do with robots or any physical aspects. So are there any other disadvantages of Python in relation to, because actually what we just have to do is to write a building in a different, write the code of a building in a different manner. So we actually only translate software to different, or how do you say it, a software code to different software code or something like that. So why would C++ be more useful for that in relation to Python? And why is Python, for example, more used for data science? Why is Python the data science language?
So there's two parts in that question. I think.
Okay. There are two questions maybe.
Yeah, the last part, because I have a question about the first part, but so first, the second part, why Python is considered to be the language for data science. It's mostly because of what I mentioned here, the large standard library. So Python has a lot of packages that make it that are optimized and make it very easy to read a lot of data and order it in the way you want, or visualize it in any way you like. And in data science, it doesn't really matter that much if, imagine you want to go over a big Excel file that has a lot of data in it, and you want to read that, and you want to filter out certain numbers that you're interested in. It doesn't really matter whether that takes 1 minute or 5 minutes. It just has to happen correctly and efficiently. And if you're working in robotics and your robot has to decide whether it has to move left or right, like if we're talking about an autonomous car, if it has to decide whether it should turn left or right, that cannot take a minute. It should know it within seconds. So their time is way more pressing in those applications. So in data science, it's less pressing, but additionally to that, it just has a lot of these packages that make it easier.
Okay, well, because that the first part, my first question, I think I should have asked them in a different order, because actually I handle a lot of data there as well, and I use C++ to do a lot of data handling. So are there any other disadvantages in that sense? Maybe if it becomes too complicated, or does Python have any limits in relation to C++, for example, or is that not the case?
No, I think the biggest difference is that it's just the performance, so that C++ will be way faster. And also in C++, you can do a lot of smart things with memory allocation. So you can tell the computer where on the computer it should store something. And Python does all those things in the background, but in some cases might do it not the way you want to do it. Okay. But for data science, I think it wouldn't really matter. But just Python would make your life easier.
Maybe that's the reason then. But I think I go into too much detail now for the rest. So thank you for the answer.